Look at this diagram showing how an AI generates a sentence. At their core, large language models are sophisticated prediction engines. They take a sequence of text and calculate the probabilities of what the next logical word should be. This predictive design is what makes AI sound so fluent and conversational, but it carries an inherent risk. The model can guess wrong, and do so with absolute confidence. When an AI generates plausible-sounding text that deviates entirely from facts or contextual logic, we call that failure state a hallucination. If you're using AI to draft a personal email, a hallucination is just a nuisance. But in high-risk environments like cybersecurity or humanitarian aid, an AI making up facts is a catastrophic system failure. So if the model is mathematically built to guess, how do operators actively prevent it from guessing wildly? How do we force it to stick to the facts? The answer lies in a single, adjustable parameter built into every major large language model: temperature. In AI engineering, temperature controls the exact level of randomness and creativity permitted in the model's predictive output. You can think of this parameter as a master switch. Turn it one way, and the AI behaves like an unpredictable creative genius. Turn it the other, and it acts like a rigid, fact-checking auditor. Let's start at a high temperature setting, approaching 1.0. Here, the system is mathematically permitted to take risks and select lower probability words. This randomness allows the AI to produce diverse, varied outputs. It is perfect for brainstorming ideas, generating marketing copy, or writing a fictional story. But introducing randomness into a prediction engine is exactly what causes factual contradictions. For example, if you ask a high-temperature AI about space, it might confidently declare that the distance from the Earth to the Moon is 54 million kilometers. 54 million kilometers is actually the distance to Mars. The model strung together related aerospace data to create plausible-sounding nonsense. Consider another famous hallucination, where a major AI launch claimed the James Webb Space Telescope took the first picture of an exoplanet in 2004, which was years before it was even built. Or when an AI insists that Barack Obama was the very first president of the United States. While a high temperature maximizes creativity, it completely destroys factual reliability, making it an absolute liability in secure workflows. Now, watch what happens to this diagram when we adjust the parameter down to a low temperature setting, approaching 0. This adjustment restricts the model's choices. It mathematically locks out the lower probability branches and forces the AI to select only the highest probability words. The behavior of the AI completely changes. It becomes conservative, highly focused, and hyper-literal, refusing to take creative risks. In this state, the model sticks exclusively to the explicit context it has been provided. If you hand it a secure internal document, it will only report what is explicitly written inside that document. By eliminating randomness from the prediction engine, a low temperature setting actively mitigates the hallucination hazard and ensures factual consistency. Understanding how this parameter works allows organizations to move from technical mechanics to enterprise strategy. Temperature operates as a core tool for AI governance. Map your settings to operational risk. On this matrix, we plot factual accuracy against creativity. In the creative sandbox, marketing tasks thrive on a high temperature, where unpredictability is an asset. But for the zero-trust enterprise, like cybersecurity or humanitarian response, factual integrity is mandatory. In these high-stakes environments, organizations must mandate a low-temperature setting to prevent operational failure. Ultimately, governing AI requires controlling its unpredictability. Leaving an enterprise AI system running at a default or high temperature is equivalent to operating without security guardrails. Active mitigation means putting deliberate, enforced parameter controls in place long before a high-stakes deployment goes live. So if you want to keep your enterprise secure, prioritize low-temperature precision over high-temperature chaos. Thanks for watching this Term Tuesday.